Okay, we're already learning bipolar transistor for the DC. Okay, and today we will start with the amplifier. At the beginning, they show you the coupling capacitor. The first one, they say good coupling. Okay, we'll be understand that a little later. Next one, capacitor will be shorted. Okay, and the last one, capacitor can be open. Let's see what they said in here. For AC analytic, capacitor is shorted. For DC analytic, capacitor is open. And if you're looking in here, capacitor reactant XC equals 1 over 2 pi times F times C, where XC will be in ohm. Pi 3.142. F will be in hertz, and C will be in farad. Okay, now I'm talking a little more about capacitor. Okay, capacitor, they can be get the positive and negative, or non-polarity. Okay, and in the AC, capacitor will be get a resistance. Okay, and we just given you the formula. XC 1 2 pi FC. XC will be in ohm. F will be in hertz frequency. C in farad. However, they get a new name. They call a capacity reactant. That means IC will be a resistance in ohm, but they get a name is capacity reactant. Okay, now try to see. At 4, I say 4 DC. What frequency equal? for the DC circuit, what frequency is equal?
0.
1 hertz.
They have to be
0.
no frequency, right? DC will be no frequency. Okay? So that's why XC will be equal 1 joule pi times 0 times C. What you think XC equal? Zero times anything will be 0.
Infinito.
How many is ohm?
Too high. Almost infinito.
Right? You can say 10 ohm, 10 kilo ohm, 10,000 ohm. Only thing I can say, infinity ohm. No number can be bigger. So for the DC, without any frequency, XC will be equal infinity ohm. Infinity ohm, that means resistance is too big, current cannot flow. So that's why we say capacitor is open. Now I can prove for you why we say capacitor is open. That means no current can be flowed through the capacitor in a DC circuitry. Okay? For AC, what frequency equal?
1 second. Doesn't the capacitor charge like at the very beginning, and then it becomes like once completely charged, it no longer has any current flowing through it.
But the question is, I said for the AC circuitry, what frequency equal 1 kilohertz, 10 kilohertz? Any number telling me what F equal? Someone say 1 kilohertz. Someone say 10 kilohertz. What do you think?
Whatever the input frequency.
I say infinity. Oh, that means nobody can tell me any number bigger. It can be a 1 kilo, 10 kilohertz, 1 megahertz. However, if we say infinity hertz, no one can get any number bigger. Okay? That will be telling you XC 1 over 2 pi FC infinity or 1 over infinity equal what?
Zero.
1 over infinity. If you learn the math, then you know. Otherwise, I given you
Y0. Y0.
0. Try memorize 1 over infinity or 1 over 0. Okay? 1 over 0 to get infinity. 1 over infinity to get 0. When you get a 0 ohm, that means no resistance. So that's why we can say capacitor
Okay.
is shorted. Okay, in AC. So you know, in here, you can see that the capacitor, they will be shorted, just like the wire. I just prove for you how. And they will be open for DC, okay? That will be everything here. We'll be telling you why they be shorted or why they be open. That's a very, very basic thing you guys should know. Okay, now, before we can go to the amplifier, I need to review few things. Okay, you know this will be capacitor connected to DC. Before you want to make sure capacitor can be an amplifier, they have to get the DC condition. Without the DC, transistor cannot working for the amplifier. Okay? And you already know the way to buy out
Okay.
faster. Too many few different ways But this is the one I really emphasize. You can calculate without any thinking, okay? The thing is we're using all the time, everywhere, using all the time. First thing we need to calculate the VB. What VB you think? What VB equal? That's what I call VCC.
10 volt.
I'm talking about the
One.
first. VB equal VCC. Times R joule. And you say 10 volt, right? Correct?
Yep.
That's what I've said. This is minimum. You learning technician, you have to calculate it right away. If you not get it done quickly, but you have to tell how do we calculate the VB. If when you apply the technician interview, they asking you, they don't asking you to do the calculation. However, they want to know how do we get the VB? Then the answer will be VCC times R2 divide R1 plus R2. After you get the VB, they want to know V. You understand it is a B. This will be E. This will be C. Collector, admitter, and the base. So what VE equal? What VE equal?
Negative
Equal what?
7.
Just talking about formula first.
VB plus
V
0.7.
equal VB, then what? What next? Okay, you understand it here. Positive here. Negative here. 0.7. They will be minus
Minus 0.7.
0.7. And they will be 9.3. Correct?
Yep.
What I'm saying is, this is very basic. We're asking you, you have to tell me right away. How do we calculate it? Otherwise, you still get a lot of problem. I want to know, how do I get IE?
RE over
9.3 over 1000.
IA, this is a VA. VA divide
RE.
RA. Okay? You can take 9.3 divide 1K. You divide a voltage to the kilo ohm, you will get a milliamp.
-3. Yeah.
And then I want to calculate the IB. Just tell me the formula. What IB
Over
equal.
beta plus 1.
Try to looking over in the past. You get IE. And I want to know the IB.
IE over beta. Beta.
Okay? IB equal IE divide 1 plus beta. I don't want to calculate it. I see. I just want to know the formula.
Beta times IB.
Exactly. Beta times I B. Okay? And the next one, I want to know VC, collector voltage. Just telling me the formula.
VCC minus IC times RC.
Okay. VCC. I see. I see. That's how do we calculate it? Emphasize here, this is very, very important to you guys, okay? The last one we want, VCA.
VC minus VE.
Perfect.
PC minus B is up.
Yeah, VC. Okay, so that means you're able to calculate everything. You want to know what a DC. Even you don't have to do calculation, but we need to know how do we calculate it. That's important to you. The thing that you understand is you can run the simulation. And same simulation, you can get everything you need. However, for interview, they just asking you to see how much you know. That means the basic understanding in electronics. Okay, any question about this circuitry? Okay, if it's not, leave it not. Okay, amplify analogy. Perform a complete DC analogy. That means before you want to do amplifier, okay, then you have to do your calculation for the DC first. Okay, short on coupling and bypass capacitor. That means the capacitor will be shorted. Visualize on DC supply voltage at AC route. So that means in the AC circuitry amplifier, you don't see any more DC power supply. The thing is they will be shorted to the AC route. Replace the transistor by its pi or C model. Raw AC equivalent circuitry. Basically, we don't have to go too much detail on that. Therefore, engineering, when they need to design the amplifier, then they have to go. But you have to understand. Now, you can see that's what they call a T model of a transistor for AC. This is a model for the transistor in DC. On DC, you see this one, but not AC. Now, see what happened. In the AC, you know, this is a collector, this is the base, and this is the ammeter. And the transistor can be substituted by the current source going from collector to the base. Okay? And also from the base to the ammeter, you get a resistance. They call it R small prime E. That one. Remember, in the DC, from the base to ammeter, what you see. This is a DC. From the base to the ammeter, what you get? From the base to the ammeter in DC, what do you think?
27.
You get it. Hello? Hello? I'm teaching, okay? Okay, can you tell me from the base to the ammeter in DC, what you see?
Diode?
Diode, perfect. You see the diode right here. The diode. However, in the AC, no more diode. And they substitute by resistance, R prime E. And that resistance can be calculated by this formula. R prime equal 25 millivolt divide IE. That is the formula to calculate R prime E for bipolar transistor. Okay, and now in here they given you a few more. What that means for G in base? How much you understand J in base? That means when you're looking into the base, how much resistance you can see. That's what they call J in base. And they will be equal the voltage from the base to the ammeter J divided to current IB. You understand that when they're using lower letter, that means AC, capital for DC, okay? If you want to see the V from the base to the ammeter, that means you want to know the voltage of V to ammeter. You take the current IE. This is the IE time R prime E. Okay, that is VE. That means the voltage from the base to the ammeter. So that will be telling you J in base, okay, equal VBE. Now you substitute IE time R prime E divide IB. Okay. Finally, input impedance equal beta times R prime E. Okay. That means if you're looking into the base of the amplifier, then you get a resistance, and that resistance equal beta times R prime E. Okay, so basically this is the definition. Okay, if you need to do calculation, you can using the formula. Now, the voltage gain of an amplifier is the AC output divided by AC input. You get a VE. You get a V out. You get the gain equal to 100. So the voltage gain equal V out divided to VE. That's a very, very basic definition. Now, the first one we will be learning. The first configuration for the amplifier, we call it CE Amplifier. Common admitter amplifier. Try to see what's going on here. Input signal applied to the base. This is your voice generator connect into the base. Okay. Output from collector. This is a collector. Okay. This is the load. The load here basically equivalent to the speaker. When you're talking, okay, your voice go to the amplifier, make it bigger, and go to the speaker. Okay. Input, output, 180 degrees out of phase. Okay. That means only telling you if you get an input, this is the input, and the output here, for sure they will be bigger, amplified. However, they will be opposite. Input positive, output negative. That's what we call a 180 degree out of phase. Okay? Or input output will be opposite. Okay? Now, see what the name of the C1. By definition here, C1 is a DC blocking or AC coupling. Okay, try to see what that means. The signal coming in, this is your voice coming here. And basically, they don't want any DC from here go to the amplifier. So that's why C1 they call a DC blocking. However, they allow your voice go through. That's what they call a AC coupling. And the C2, at this point here, you can get two different voltage. First thing, the DC voltage to make the transistor working. Also, this your voice here, they go and up here. So you get also AC, your voice signal. However, when you go to the speaker, they don't want any DC from here go into the speaker. So that's why you need capacitor C2 will be DC blocking. That means they not allow any DC from collector go to the speaker here. But they will be allowed your voice to go. So that's why AC coupling. So to your guys, if I asking you what the name of C1 in this circuitry, the answer will be DC blocking or AC coupling. That means they block DC, but they allow AC to go. Same thing for capacitor C2. DC blocking, AC coupling. And the last one, C3. C3 to go up by part capacitor. Now, by part what? What they will be by part?
RE.
You understand? You get a sine wave coming in. Okay, and here you supposed to get a sine wave. In here, you supposed to get sine wave, but did the opposite. So now they say C3 here by part capacitor. What by part what?
Resistor of emitter.
Okay, now C3 they go by part capacitor. When they say by part capacitor, so C3 will be by part what in the circuitry. Now I telling you, capacitor open for DC. Coupling AC. They're telling you capacitor will be open DC but will be shorted for AC. So now if the AC capacitor will be shorted. Just like the wire. So that's why when you get an AC here, AC not go to RE, AC will be shorted to the ground. That's what they call a bypass. Bypass what? Bypass RE. They're telling you the AC current will be go this way. IE. They not go through RE. The thing is, capacitor C3, they shorted. So they go to the ground. So when you measure at this point, at meter, you cannot get AC signal.
So when there's
They
a
get
short,
shorted to the
it
ground.
goes to C3, right?
C3 will be short, go through C3, not say equal C3.
So, but all right, bypass.
So if you measure AC signal at this point, you cannot get anything. They will be short to the ground, so you get 0. That is the purpose for capacitor C3. And later on, when we go more detail, you can see they can get C3 or they don't have a C3, that'd be fine. If they don't have a C3, then current IE will be go down here. However, if you get a bypass capacitor C3, this current IE cannot go through IE. They go to C3 to the ground. That will be help to make the gain of the amplifier bigger. Okay? That is the
Okay.
purpose for bypass capacitor.
When there's a short.
Yeah, C3 will be shorted for AC. So, what I want, when you're looking into the amplified circuitry of the transistor, you have to know the name. Later on, you can see, you can get a CE amplifier, CC amplifier, CB amplifier. That means 3 different configurations. But by looking into the circuitry, you have to know CE, CC, or CB. Now we're talking about CE. Input applied to the base. Input here applied to the base. Output from collector. Okay, that will be CE amplifier. That is the first step. Recognize what the name of the amplifier, CE, CC, or CB. So you can take what is a C1, C2, and C3. Okay, C1, DC, blocking AC coupling. C2 the same. C3 will be bypass capacitor. And the input and the output will be opposite. Input positive, output negative. Input negative, output positive. That's what they call a 180-degree our phase. Okay? Any question on that one? Now,
When
if
there's a
we
shift,
have little more. Okay, if they draw for the AC, what 10 volts supposed to connect you? If you're looking on this circuitry, what 10 volts? We already telling you, you don't have a 10 volt DC voltage, okay, in AC. So how do I draw the connection for 10 volt in here?
you gotta make a force connection.
To the ground.
Let's see. Here. Visualize on DC supply voltage at AC ground. They're telling you that now they will be ground. Right now we're talking about AC. Okay? If we already calculate for DC ready at the base, how many volts you get? Right here. Right? You're using the voltage divider. You calculate, you get 1.8 volt DC. How many volts here? DC. We're talking about DC. VC.
$1.1.
They already calculate for you in here. Okay, now telling me what DC wanted VE.
1.8.
How come you get 1.8? They already calculate for you right here. 1.1. In order how to get 1.1, you get 1.8 volt VB
1.8.
minus 0.1 1.8 VA equal VB minus 0.7. This is what they already calculate for you.
1.1.
Okay, they put it in here. They're just telling you that is a DC voltage of the circuitry. And what happened 6.04? That's what voltage. If you're doing calculation like I just telling you, you can get that answer. Okay,
Yeah,
this picture will be help you when you try to working on the circuitry. You know what the signal at a certain point will be look like. For the AC, so you don't have a 10 volt here. The thing is, DC voltage will be short to the AC route. Okay, now, at this point, at the base, how many signals you get?
5.
How many signals?
Oh, just 1.
You said just one. What is it?
The 100 volts.
1.8 volt. Right?
Yes.
That's
Yes.
a DC. This is your void right here. Also, they go to here. If I said, I can give example. 20 millivolt peak to peak. That means the sideway. 20 millivolt peak to peak. And you can see they draw that this signal on this signal will be the same. So at the base, you get 2 signals.
DC and AC.
DC will be 1.8 volt. AC will be 20 millivolt peak to peak sideway. Okay? Now, when you're looking into oscilloscope, how they will be look like. Okay? on the oscilloscope, that will be 0. And the first thing you can see, you get DC 1.8. Okay.
Mm-hmm.
How about signal? 20 millivolt peak to peak.
Funny.
Plus AC voltage.
They will be here. So basically, that will be a 10 millivolt. It
System.
will be 10.
Oh, yeah.
That means in the middle, 1.8. That's what I showed you. So when you're working on your left, you're looking at the point B. That's how come you see that kind of signal. This is a 0. Normally, if you don't have a DC, then the sine wave will be go this way, right? 0.
Around zero. Around the zero.
Okay. However, when you already get a DC, so basically the sine wave must be C, look like same thing in collector. You see that?
Yes.
This is your signal, your voice. You can see the opposite to the input. The 0 go up. Okay. However, at the point C, you get 6.04
Point zero.
volt. So in here, you can see this is a 6.0.4 volt. Okay. This is your signal. However, this is go to the speaker right here, the load. You can see this signal.
0.
What different? You don't
26.
see 6.04, right? In here, you don't see 6.04 volt, correct?
Correct.
Why?
Only the AC.
Why you don't see any DC voltage here?
C.
Because of C2.
Perfect. C2 DC blocking.
Oh,
That
yes.
means
C2 is blocking.
6.04 cannot go through. Okay? Basically, your voice go to the speaker, you don't want any DC. Okay? I hope you can understand.
So why you still got frequency?
But
That's a feedback or what is it? On
now,
0.
0 here, just telling you, if you're looking at it on the scope, then this is a 0. And this is your output here. If you're looking compared to the point here, you can see this is to get a 6.04 volt. And this is your output here. But when you go to the load here, C2 will be blocking 6.04 volt. Only sine wave coming out. That's why you see 0.
Mhm.
So that's why when you measure at the output here, you say you can get signal look like that one. And you know the problem with the capacitor C3, C2. They're supposed to block DC, but they not. That's why you can change C2. Okay, when you looking signal at the meter, do you see any sideway at this point?
No.
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 The thing is sideway will be short to the ground. C3 will be by path.
So can't come back now.
By path means short to the ground. So this give the AC.
The shorter.
Yeah, shortest to the ground. If you measure here, you get a sideway like that one. What happened?
It's not filtered yet.
Not by path, right?
Yeah.
That means something wrong with the C3. Supposed to be by path, it's not. That's why you get sideway here. So AC current go this way. And we don't need that guy. Right? The thing is the current not go to it.
So where did it disappear?
Which one is disappear?
Okay.
What I'm saying is, if you're looking at this point, you cannot see this sideway. AC, they will be short to the route.
There's no lead to show the shorted.
Yeah, when you measure here 0 AC, that's why they have to be short so to the route. So that's why you cannot see this signal at this point. But that's how you take short. You see here, you don't have a sideway. Okay? That means C3 is shorter. If you want, try. You can remove C3. Now you can see sideway here. So basically, the current IE, they go this way. They not go to 1 kilo ohm. So basically, you don't need that one, right? For AC. So bypass mean what? Mean bypass 1 kilo ohm. Okay, so this one, the textbook, just try to telling you, okay, if you get the CE amplifier, then you can get the DC voltage here, DC voltage here, DC voltage here. And also telling you, you get a sideway applied, okay? Input, you will get sideway at this point. You will not get sideway at the meter. At the collector, you get a sideway. Also, you get a DC. Okay? However, at the output to the load, you don't have any more DC. You get only sideway. That's very good for the student. Okay? When you try to troubleshoot it. Okay? Any question? Okay. Okay. Next one. Common meter amplifier. They're using completely T model. Okay. First thing, this is the circuitry. Okay.
Mhm.
Now, this is the circuitry. They combine DC and AC. Just telling the technician to know at a certain point what DC voltage you get and what AC signal you get. Okay? And make sure when you're working on CE, you have to measure the output, inputs, sideways. They will be telling you. You measure at this point. You can see the sideways will be in the middle will be 1.8 volt DC. However, for this one, completely AC. Okay. So that's why you don't see any DC here. First thing, this is the base. This is the collector. This is the ammeter. We already know for the AC from the ammeter, from the base to the ammeter. You're supposed to get, ammeter here. This is the ammeter. This is the base. Okay. The current flow, we see current flow here. IB. Current flow here. IC. IE. We already telling you in the DC from the base to the ammeter, you get a diode. However, for the amplifier, then from the base to the ammeter, now you get the resistance. That will be R prime E. And the formula to calculate resistance equal 25 millivolts divided to IE. Okay? And you don't see any DC power. No DC in here. Okay. Understanding what they call common ammeter. What that mean? That means at meter will be round. That is common at meter. Common collector. Collector will be round in AC. Common base. Base will be round in AC. Common at meter. They're telling you at meter will be round in AC. Now you understand when they're talking about common at meter, common base, or common collector. Okay? And then,
Okay.
any questions? Okay, go back to this one. If you get this R1, this R2. So, from the base to the ground, that's R2, right? That's why you can see right here. From the base to the ground, R2. Okay? What happened to R1? R1 here. R1, one side connect to the base. The other side connect to 10 volt. What's a 10 volt in here?
Connected ground.
Where 10 volt? No more.
And go to ground.
Connect to the ground. So that's why R1, one side connect to the base, the other side connect to DC ground. DC 10 volt. Now they ground. So that's why you can see R1 now, R2 in parallel. Okay,
Mm-hmm.
good. Now we're talking about at meter. At meter here. Okay, so basically at meter will be routed data inside the transistor R prime E inside, okay? So at meter will be connected to ground. However, telling me at the collector here, okay, see how many things you get. First thing, you get RC, this RC. That's what we call R load. So at this point here, how we connect RC? That's a collector. RC connect one side to the collector. How about the other side?
To the ground.
Perfect. That's why you see RC right here. One side connect to collector, the other side connect to ground. Last one, IL. One side connect to the collector. The other side connect to ground. So that's why you get RL here. Okay?
Mhm.
That's why I try to given you okay. How come we from this circuitry okay, and we go to the next one. Now you understand why R1, R2 in parallel, RC and RL in parallel. Okay. So, any questions on this?
Why this one it doesn't have any emergency exit? Is this is a different model? Is an amplifier?
You mean a different module?
Yes.
Yeah, they can be get another pi module. Okay. But this is a one. They call a T module. Okay. What I try to do, I try to telling you from this circuitry, when you completely go to the amplifier, then now they will be this circuit.
Okay.
Okay. So when you deal with the amplifier, that means you have to deal with the input impedance. That means input resistance. This is your input applied here. So when you're looking from here into the circuitry, that's what they call a G, input impedance. The unit will be in ohm, that resistance. Okay? But they call a input impedance. And they can use in R in G
Parallel.
they can call the different names. But if you're looking from the source sideway to the amplifier, whatever resistance you get, that's what they call an input impedance. Now, if you're looking into that, what can you see? What G is supposed to be equal?
Parallel of the two.
Parallel. Which one parallel?
R1, R2, R E prime.
Now, you are very, very close. You can see R1 parallel R2. Okay? And also you can see from the base to the admitter, you get one resistance.
R1 to RL mesh.
This resistance, they call a
RE.
B.
Oh, RB. Yeah, it was all right.
Okay, I will get.
RB is what that means. That means resistance from the base to the ground. Okay? When they say RC means resistance from collector to the ground. RE resistor from ammeter to the ground. RB, resistance from the base to the ground. And you know RB Ohm law V B divide by B. That is, you get three resistors in parallel.
Okay.
R1, R2, RB. And you know RB will be equal VB divided to IB. The thing is, on amplify, they only deal with what? Deal with the input impedance, output impedance, and the gain. Now, output impedance, that means you're looking from the output to the amplifier. They can say you get a G out. Now, what G out you see equal what? If you look
RE.
into the output, what you see? What G out?
RC
Equal.
and RL.
We're talking about impedance, output impedance. So from the output looking into the amplifier, I can tell you, I can see RC parallel with
RL.
IL. That's it. So that's why you can see they give it to you right here. RC means G out. So depending on the textbook, okay, RC here, R means resistance, C means collector, lowercase letter, that means the AC, that means the output impedance, okay, and this is the V in, this is the V out. So you want to calculate the gain of the amplifier. You take the V out divide V in. So that is a completely for the common ammeter amplifier. Okay, any question, anything?
Okay.
So make sure you look over and over. I don't asking you any calculation. We don't care. But we asking for understanding. Okay? That will be helpful your guys to do the job. Okay? So that's good enough for today. Okay? Next meeting, we're talking about common collector, common base. But the first one will be the basic. Later on, they almost the same, only a minor difference. If you understand common ammeter everything, and no big deal. You're working with a common collector or common base. And you're working on the level. You will be working on this circuitry. Okay. And the last question I want to asking you. When you apply the sine wave here, that from generator, they say 100 microvolt. Now, first thing I said 300 millivolt peak to peak. So basically, you connect to the generator.
Peak.
Okay. When you connect to your generator, basically your generator can be going down. Maybe you can get minimum for amplitude. Maybe you can get to 300 millivolt peak to peak. However, sometimes you cannot get up to this point. What can you do? How you set it up your generator to get a smaller voltage?
Generator.
You have to pay attention on minus 20 dB button, right? You have to using the minus 20 dB. So you're able to get down up to 300 millivolt. That only one you can get up to that millivolt. Remember, I don't have a generator in here, a scope in here to show you meter type on Friday. You have to emphasize on that. That means if you want the small voltage, then normal output of generator given. You have to using the button minus 20 dB. Then you can down to 300 millivolt. However, one more question here. When you get to 100 microvolt, or 10 millivolt,
Generator.
how can we do to get that voltage? The thing is, when you turn on generator, you're using the button for minus 20 dB. Try to bring it down to small voltage. That's the voltage you can get. However, now the lab asking for, they want 10 millivolt peak to peak. Then what? Who know how to do? Okay, I'm telling you. Lab one already prepared for you. That's what they call a attenuator.
Generator. Yeah.
That will be in. That will be out. Okay? That means when they build the board with a CE Amplifier, they will be given to you. We call it attenuator. So you connect this into generator. And the output here connect to circuit. The thing is inside here, alternator, they get the voltage divider. They divide it down and down and down to whatever you want.
To reduce, right?
Yeah. So that's why, when the left volt they build, they already know for sure generator cannot make 10 millivolt peak to peak. That's why they already prepare for you the circuit in the CE amplifier. Output generator connect to the input of the alternator. And output will be connected to your circuit. Okay? So good luck for everyone.
Okay, thank you.
Okay.
Teacher.
Thank you.
Welcome.
Thank you, sir.
Okay, so we will stop here. Good night, everyone.
Good night.
Good night.
Good night.
Thank you.
Bye-bye.
Bye-bye.